Thanks, Sarah. Thanks, everyone, and for joining for the latest in the ESCO webinar series. I'm Stuart McIntyre, Professor of Economics at the University of Strathclyde and part of the ESCO leadership team. And I'll be chairing today's webinar, where we will have a presentation from Anna Galvão of some of her latest research on tracking weekly activity using new data sources. Anna will speak for about 40 minutes or so. We'll then turn to Andrew Walton from the ONS, who will provide 10 minutes or so of discussion, and then there'll be time at the end for you to ask any questions that you have. In terms of housekeeping, if we can just ask that if you have a question, if you use the Q&A function of Teams and you put that in there, it helps us to manage the questions when we get to that part of the presentation. If you can't get that to work or you can't find it, please use the chat function instead. What we'll try to do as appropriate later on is to ask you to unmute and ask your question. But if for the duration of Anna's presentation, you can put questions into the Q&A, that would be much appreciated. So without any more from me, let me now hand over to Anna Galvão, who's going to talk to us about tracking weekly activity using new data sources. Anna?
Thank you for the introduction. I'm Anna Galvão. So this work is joint work with Andrea de Polis, that's here too, and is here to answer all your tough questions about the model. Is actually joint work with Vivan Petrella. I'm included at Bloomberg Economics, so I wanted to say that these are my views. They don't reflect the views of Bloomberg. And Andrea also has a disclaimer because he's included at the Bank of Spain, so this is his own views, not the views of Bank of Spain. I also want to thank ESCO for funding this project. He funded the support Andrea for his postdoc. So thanks for that. Thanks for that. We were actually able to do this project. So let me start talking about what we've been thinking here in terms of tracking activity in real time. So there'll be a large source of new alternative data come up, in particular during the pandemic, because governments wanted to have a sense on the impact of the pandemic on the economy. So there was loads of different types of alternative data. So they include things like mobility data, card transactions, online jobs adverts, restaurant bookings, VAT changes in reporting, things tracking amount of shipping imports, about flights in airports, and also retail footfall. The ONS started and published actually a number of real-time FASTA indications since then. And the question we try to address in this research is actually figure out, can we use these indicators to track macroeconomic activity? Which kind of information they can have? So let me start give you some examples here of how these have been published. So this is from last year's publications by the ONS. So you can see that you have a different set of time series. Here I actually have one of the time series we're going to use. We're going to be using debit card spending. The source of this is Revolut. But you see there's other things that UK retail footfall. And then you can see that in the top, you have different tabs because they're based in different categories. So you have like for the business and workforce category, you have things like the new online job adverts. And this is actually one of the other series we're going to use, but we have other things like potential redundancies, VAT new report is the one I was talking before, employee proposing redundancy and so on. So there is a variety of these real-time indicators. So they're nice because they're being published every week. So it's to get a fast track of the economy. So the question is, are they useful? So this is one of the kind of exercise we're going to do in this research, which is how useful is the debit card data to track retail sales. So we're always going to connect a indicator, a high frequency indicator at a weekly frequency with a monthly indicator, okay, our official statistics. So here you have actually the non-seasonal adjusted nominal retail sales for the UK. So you can see it's very seasonal, it's available for a long period. And then you can see that you have this other alternative data series, like there's three types of spending here from Revolut. There are the total index that's computed plus a grocery component and a shopping component. So you can see that this index is available a much shorter time series. So it's from 2020 instead of being from 1995. But you can see there is some jumps as well. So there is some clear seasonality. And of course, we're going to try to use this to try to track the overall change in retail sales. So this is one of the examples we use. The other one is this one. We try to use the same series, but then we put in real terms, and this is the overall spending. And we try to see if we can say anything about monthly GDP series produced by the ONS. The other one is using job adverts. So the green line here is job adverts, and then the black line here is vacancies. So you can see the vacancy here is seasonally adjusted and so on. The series we may try to get some information on is much more jumpy and much more noisy. So you can see that in terms of kind of challenges that this data bring in, is in terms of the noisiness. So if you think about it, is that, you know, the official statistics are normally monthly or quarterly. We're going to constrain to monthly. These indicators are weekly, so it's great for real-time tracking, but the time series are short. You saw it's only 4 or 5 years of data. There's clearly some seasonality, and it's not clear how the seasonality we have in this high frequency indicator is related to the seasonality of the official statistics. And that's why it's nice, that example with the retail sales, because retail sales has a natural seasonality. So it's a question whether that kind of annual seasonality there is related with the seasonality of that spending. It should, right? But how we can measure that? Other thing too is that not only the sample is short, as we have to account for the issue of the pandemic outliers, and how to handle that when you try to extract the information out of the data. So our proposed approach have the kind of following features. First, we're going to model jointly seasonality. So we're not going to seasonal adjust data and then play with seasonal adjusted data. We're going to have seasonal terms. And actually, this is nice because the model would seasonal adjust the data and also would allow to seasonal adjust the high frequency indicator by using some of the information on seasonality from the low frequency indicator. So we think this is a kind of interesting feature. The other one is we're going to use, the model allows for fat tail distribution of the disturbances in such a way that we can able to track and get some more impact from outliers. So this is some of the features we have. Now, hold on, sorry. Now, which kind of literature we contribute to, or which kind of literature inspires us to do the model that I'm going to show in a bit. So if you think about it, the Aroba, Diabone, and Scott, which is now still published as the ADS Philadelphia Fed Business Condition Index, it was an earlier kind of modeling in which you try to track activity in real time. So there was a model to track GDP. And the idea of the authors was to use a small set of monthly variables, so it was sales, income, industrial production, payroll, and one weekly variable, which was unemployment claims. And the idea that would allow you to give a weekly measure of GDP, okay, using a kind of small dynamic factor model of common filter. This has been standing over time in the nowcast models, right? So the Bambura, Geronimo, Doni, rightly, they have that kind of survey of nowcasting models, and the kind of models they have. They normally try to track again quarterly GDP using as a set of a monthly series. So they include some official statistics and also what they call survey-based and measure things like PMI, for example. So you have a combination of a large set of series and you have a mixed frequency problem between monthly and quarterly data. More recently, you have this paper by Antolin Diaz, Dresch, and Petrella that they try to improve the dynamic factor model to accommodate some issues, including this COVID issue, and also to accommodate stochastic volatility. Actually, if you look, for example, one of the providers of nowcast models, the New York Fed stopped publishing their traditional nowcast models based on DFM some point in 2020-21, and then come back a couple of years ago with a reformulated model that does account for the outliers of the pandemic in a different way, add stochastic volatility and so on. So there's been a evolution there on the kind of model used for this kind of problem. Something that was very cool during the pandemic was this weekly GDP tracker. So by Luz, Mertens, Stock, and Trived, this actually is based on a much simpler kind of approach. So there was no filtering there. It's more like extract a factor and link to GDP, but use rich 10 different weekly series, and that use both official sources like the unemployment claims and actually private source data. So you start adding these more private sources. And also the other paper I want to talk about is also this the Chicago Fed tracker for retail sales by Brave et al. So here again you have the kind of frequency of data that we have here in our paper, which is a combination of trying to track something that's monthly with something that's weekly. Using in their case, they use a set of indicators. Again, it uses a bit of private data and official data, and actually very alternative data as well. So the difference that we have from them is that they seasonally adjusted everything. And as I told, one of the main features of a model is to try to model seasonality together with the kind of information we're trying to get out of the high frequency data. So let me now go into details what kind of the main features of our approach, right? So I kind of a bit explained what we're actually trying to do. So we're trying to get a weekly estimate of a monthly official statistic. So this has two uses. You can have a weekly retail sales if you want, or you can try to anticipate the value of the retail sales that's going to come up. Retail sales doesn't come up with loads of delay, in 2 or 3 weeks delay, before that's released by using the information you already have on the real-time indicator. Okay, so they has this kind of two types of uses. Now, which kind of, I'm going to try to describe more or less how the structure for our model works in words. So for the official statistic, so think about it, that my example, I'm going to move back to the example here. My example here, you have retail sales. So imagine that's the official statistic. And then you have the debit card data as a kind of the high frequency alternative data. So for the official statistic, the assumption we're going to do is the following. The data is decomposed into kind of components. One I'm going to call level, which is the one that includes the trend and the cycle. And the other one that's the seasonality. You saw my retail sales has seasonality. So we're going to assume that for the trend, you have a stochastic trend. So you're going to model the cycle by model the data in first difference, so kind of growth rates. And then the cycle process would have a persistence. So you're going to have autoregressive process. And also it would include the average of the weekly data over the month to try to capture a bit of long memory. Okay, so this is a kind of, we try to make the dynamics of the cycle as simple as possible under the assumption of stochastic trend. Then you're going to have innovations to this cycle component that also move the level component. And they're going to come from a fat tail student distribution with stochastic volatility. So this is what we use to capture slow changes on the variances of the shocks to the series over time, and also to account for issues of very large errors during some specific periods during the pandemic. In terms of seasonality, we're going to follow Harvey and use harmonic functions. So this is going to be the way we're going to try to model seasonality here using the traditional way done by Harvey. Now, in terms of the high frequency data, so this was about the low frequency data. So low frequency has level and seasonality. High frequency, you also have the same level because you want the high frequency to inform these level components, which is what's going to be our tracker. And at the same time, you have some additional components in such a way that the high frequency data can inform what we wanted to track, but at the same time, removes the bits that are not very important for the weekly tracker. So the bits that we add in, including two seasonal components. So one is seasonal over the year, so it has like the monthly seasonality, January, February, and so on. And another one that has a seasonality within a month. Okay, so the one over the year will be shared with the official statistics. So this is actually a nice way to use the much longer time series we have on the official statistics to try to help us to disentangle those two seasonal components, which means we could have seasonality for the high frequency series even over. We can measure basically the seasonality of high frequency series. Otherwise, it's very hard to do when we have only 5 years of data. Okay, I told you the share, and there are two. The regular component here, we're gonna have a bit of persistence because to capture a bit of some deviations, some persistent deviations between the official statistic and the high frequency data. And other thing you should know is that we kind of use a strategy to aggregate between the monthly series and the weekly series, a regularized calendar in such a way that we reorganize the data in a way that you always have 4 weeks in a month. Okay, in terms of findings, so the question is, does this work, or through the lenses of this model, do I find information on this high frequency indicator that could help me to track the official statistic? The answer is yes, I do find it. So the targets I already show you, we're gonna have the retail sales, monthly GDP, and vacancies. The high frequency predictors is gonna be the debit card data and the text kernel new online adverts. And we're going to disentangle a bit the debit card data between the two components that we think were more linked to retail sales. And we find that the transactional data is useful to track retail sales and monthly GDP. And the way we do that, we do a comparison. So we compare two models, one model that does have the information of the high frequency real-time data and a model that doesn't. And by comparing them in real time, we will find that the high frequency indicator does add value. So that's the way we do it. And we'll also find that the online job ads are useful for tracking vacancies. So although it looks pretty noisy, once you pass to the filter and pass to the model, we are able to find some relevant information. So I'm now going to go in detail on the model. So I'm going to start showing you some equations. So I hope that's okay. So I'm going to start talking about how we model the low frequency variable. So YTO here will be the observed variable, will be retail sales or GDP in logs. Then, of course, we have known weights that kind of aggregate that's linked to this unobserved time series here, which is basically the high frequency weekly statistic. And the idea is that the official data, of course, is just observed every month, while this Y star thing will be observed every weekly once we're able to compute. Now, so as I told you, this Y star here is going to be related with the level of the series. And the level of this series, you assume it has a stochastic trend, which means we're going to model in first difference, okay? So basically, if you think about the first difference of the level is kind of the cycle of this series. It follows this autoregressive process, and then it has this term here with a L4 bar thing. So L4 doesn't mean it just means it's average over 4 weeks, okay? This is our notation for that. So the idea is that you have, remember, this is going to be weekly. So you have the weekly differences as a function of the lag weekly difference. And then here you have the average over 4 weeks. Now, why we do that? So this is something I've done before a long time ago in the finance literature. It's basically a way to account for long memory. It's a way that doesn't allow you to put loads of legs in here. You kind of is a parsimonious way basically to capture a bit of persistent long memory. And this is what we do here. So this is how we model the dynamics. Then this U here, which is going to be the irregular term, it's modeled by allowing for stochastic volatility and by allowing that the innovations come from a T-distribution. So you have a fat tail distribution and you have innovations with stochastic volatility. So this allows for the conditional distribution to change over time, okay, of the disturbance. So this is to capture all the issues related with COVID and so on. This is basically how the seasonality works. So actually I forgot to put the equation here that tells you that the official data, then the unobserved official data is going to be a combination between the level and the seasonality. So this is the seasonal term that would go on the official data. So it comes from these harmonic functions, which are functions of sine and cosine functions. It's basically a traditional way to deal with seasonality. The main thing we need to estimate here is actually the variance of the seasonal terms. So we have variance of seasonal terms and variances of the stochastic volatility process. And those two things need to be well calibrated and well estimated. Otherwise, a component might dominate the other. I'm going to show you the results in a bit and exactly how we do. Actually, the way we control this, we do Bayesian estimation. So we're going to have specific priors that are able to control the estimation of all this process while we're just using as observable, say, retail sales and Revolut debit card data. This is basically the process we assume for the high frequency indicator. So here I put the full equation. So you have here the high frequency weekly series, and you can see that it loads on the level. So this is the bit that also loads on the official statistic with a coefficient 1. So here you have this coefficient gamma. And then you have two seasonal components. So the annual one, which is the one that actually gets in on the official statistics as well, and the monthly one, which is the within month seasonality that's only getting on the weekly data. And then here you have a regular component. Okay, so remember this STA is shared with the official statistics, okay? And again, the other seasonal term, it follows the same kind of structure that the previous one I showed you before. Again, you need to estimate the variance to be able to capture the seasonality here. Okay, something that's important when we start estimating this model, actually done by Andrea, so that's what Andrea told me so, is that once you start working with this model, because you have all these components, the variance of each component is very important to be able to control which variation goes to each one. And basically what happened is that during the pandemic, when we started having that big jump, some of the jumps were going to the seasonal component instead of going to the regular. So we have some control on the prior variance for some specific big swings on the pandemic in such a way that the jumps do go to the regular instead of go to the seasonal component. And the irregular component for the high frequency has a zero correlation. The reason that happens is that captures some bias deviation between the official statistic and the high frequency indicator. So this is what that does. Okay, in terms of estimation, this is going to be done with Gibbs sampling, so we can control a bit of the estimation by imposing priors. You have to filter out the latent states here, which includes the level, the seasonal, and the irregular components. Remember, the level is the joint bit. If you want, it is the factor between the two series. Note as well, I forgot saying, is that you can see that this equation has an I in it, because you don't need to have just one high frequency indicator. You can have a collection of them. And so this approach could be applied to many. And so this has to be taken into account as well. And you have the irregular component. Okay, I'm gonna show you fast here because this is even looks more dense than my previous slide. I'm sorry, but let me just highlight the main features here. So the latent states, they all draw using what we call a precision sampler. So basically what that is basically a way to run something that looks like the Calm filter, but much faster using matrices. This is from Joshua Chan. The draws of the other coefficients are done in the traditional way, and in the paper we have a list of priors. I think the only other thing I already told you about the seasonal variances. So you see you have 3 of them. You have one for the monthly within month seasonality, one for the within year seasonality, and one for some specific points in time in 2020. So the outliers, pandemic outliers, don't go to the seasonal, because otherwise if it does it, then you're gonna have this thing contaminate the seasonal in the future, which is not something you want to have. We have the traditional way to draw stochastic volatility using the mixture of normals algorithm. And you also have a way to draw the t-distributed error using this combination between inverse gamma and Gaussian distributions. Okay? So this is the Gibbs sampler. So remember, basically the idea is that you keep running over the sampler many times until it converges. Okay, let me show you some results then. So this is about the retail sales and app card spending. I already showed you this plot. This is basically how it looks, the tracker, okay? So remember I told you the tracker will be the level component. So the original series is something like the black line here, which has full of seasonal and it has a trend. That's the only thing you can see. And this is basically how will look the estimated weekly series. The bands here, the widest ones are 90%. They have 90% coverage approximately. So you have a 5% probability of being outside these bands. So this is from the Bayesian estimation of the model. So you can see that, you can clearly see there's more variation after 2020 when we have the information, the high frequency indicator, and less before, okay? Because before the only information we have is the time series on retail sales. And of course, if we move the seasonal components and they were regular, after that, you have much more information. And you can see that on the bands as well, the bands shrink because you have less uncertainty about how to capture this weekly version of the originally monthly retail sales. So this is the tracker. Of course, you can then move this tracker for the future when we wanted to do forecasting. This is the full sample estimates. And then you have some of the components. So on the first plot here will be the seasonal component on retail sales. And you can see that when you add the high frequency data actually helps a bit with them. You can see you have a narrower band even on the seasonal component here. Then this one in the middle is the seasonal component on the Revolut data. It's a bit, so this is the bit that is within months, and you can see it's quite different from that one as expected. And then here you have the irregular components. You can see that there is a bit of missing seasonality still in these irregular components here from groceries and shopping. And you can see here as well that we're using two high frequency series to inform on the low frequency variable. But basically putting all this together, you're able to get the tracker I showed you before. Actually, by removing all this information, you're able to get the tracker I showed you before. And this is one way to just figure out how this is working, because when I show you a data like this with trends, it's hard to know if it's right or wrong. So if you use year-on-year growth rates over that number, so our fitted values is the blue line and the actual data is the red line, and you can clearly see that it does much better when you start adding the information coming from Revolut from 2020 onwards. So you have a much better track between the blue lines and the red lines. Here there's this miss here. Here you start not having, although there is a bit of a miss there, but it does have information for it, which is our point. But we're gonna do a real-time exercise later to provide you more convincing information that that's the case. This is for monthly GDP, so this is the tracker. So the original series which I didn't put in here. Sorry, I should have. So the original series is here. So the monthly GDP is seasonally adjusted. So you wouldn't expect to have a seasonal terms, but we do keep the seasonal terms there just to be sure that they are zero. And of course, in real terms, so we have to remove the impact of CPI on the Revolut data before we do the analysis. So so this is basically the tracker. Then here you have the components. So you have here the seasonal components on monthly GDP, which you can see 0. And then you have the seasonal component with month for the Revolut data. You can see some here. So there is some seasonality there. And you can see that the regular component has a bit of a trend here, which means that there is the Revolut growth rates are much faster than the ones implied by the monthly GDP. But remember, once you put that in the regular component, that is not going to contaminate, the tracker, which is what we wanted. And then here you have year-on-year rates, again, because otherwise you cannot see anything. And you can see that here you have a quite very good fit, okay? So the question then is whether you do need this weekly data from Webcard data is buying or anything. I'm going to show you again some results on the real-time exercise if you're not convincing this is adding any information yet. And this is the final exercise in which we use vacancies and online job adverts. You can see the online job adverts is a bit longer than the other series, actually starts in 2018, but it's full of these funny jumps in. So the question is whether the model is able to let this go to the regular component and not contaminate the tracker. So this is how the tracker looks like. You can again clearly see that the amount of uncertainty you have reduces when you add the vacancy data. You can see here that you can have this weekly vacancy time series by doing this. And this is the components. So vacancies, no seasonality, but you do have the seasonality here on the online job adverts, and it's captured by this term here. And then here you have again the irregular. I told you there's a bit of bias here, so it seems that the online adverts grow much faster than the official statistic in some point here in 2021, most likely. So the irregular does sometimes capture some of these big deviations, but the question then again is whether it does inform in real time. And this is the last thing I want to show you. But before that, let me just show you this. So this is again is the year on year. You can see that when you add the information on the online adverts, you have some issues here because the tracker would then decline faster here than a bit the data. But otherwise, it seems to be doing really well to capture the vacant series. So let me show you this, what I keep on talking about and not showing you the results, which is basically the results of the real-time exercise. So basically what we're trying to do here is the following. You have two models, okay? One model that only has the official statistics, and the other model that has the high frequency indicator. Then you sit on week 1 of the month, so the first week of the month, and you try to compute then the tracker for this week and also for this month, and for the next month, okay? So these numbers here are ratio of mean square error. So the fact that they are smaller than 1 means that the tracker that has the high frequency data performs better than the tracker that only has the official statistics, okay? So you can see that for example, for the retail sales with the debit card spending, you have an improving mean square of about, I don't know, this is 60%, and the same thing here, okay? And then, of course, this improvement gets a bit smaller over the next, gets better for the next few weeks. Andrea, I'm doing the interpretation right here. Can you help me?
Yeah, no, this is correct. So these are ratios, and sort of the improvement is if you interpret like the other way around the columns, like this is the weeks of data that you have in the over
Yes.
the month. So like sort of as information accrues, like the mean square error sort of improves.
Right. Yeah. So the mean square will be important, so it improves over the period.
Exactly. It's not always the case, but this is sort of something that
Yeah,
is
it's
known.
not the case with the job ads, right? That goes in the other way around. Is that what you want to say, Andrea?
Yes, exactly.
Yeah. But the important thing in terms of the real-time exercise here is that so these numbers are much smaller than 1. So you can clearly see that the high frequency indicators are adding information and they are improving the tracker when time passed by. Most of the cases, not always, as Andrea said. Other thing, when we have the 2 different time series separate for debit card, it does a bit worse, but this is what it is. And we have slightly more difficult for vacancies using the job ads. You saw the job ads was a very noisy kind of series. But once you have loads of information, like in week 4, you do better. Okay, so this is the way I try to see this table. So we kind of use this table in the paper to show that clearly we can extract information of this noise series that can help us in real time. And so we have 3 minutes, but I'm gonna conclude now. So basically what we're trying to do here is a combination is a state space model done with Bayesian methods with the clear aim to try to extract information from this noisy real-time high frequency indicators such we can track official statistics. And I think that there is loads of it looks like from this kind of real-time evaluation we did that these alternative sources that have been published by ONS over the last couple of years are really helpful to track some of these ONS statistics. Okay, so I guess I stop and let Stuart take hand of this.
Thanks, Anna, for what was a really nice presentation. For just handing over to Andrew Walton from the ONS, who will take 10 minutes or so to provide a discussion. Just while Andrew's loading his slides up, can I just remind colleagues on the call, if you do have a question for Anna, please use the Q&A function, and we'll pick up those questions after Andrew's discussion. Some are already coming through, but I've just encouraged colleagues, if you do want to ask a question, then just register that in the Q&A. Now I hand over to Andrew for a short discussion of Anna's work.
Thank you very much. Hopefully the slides are showing and you can hear me. I was having a few technical issues with the camera, but I think it's okay now.
Yes.
So yes, good afternoon. I'm Andrew Walton from the ONS. For the past 16 years now, I've been the senior statistician in national accounts, responsible for monthly, quarterly, annual GDP, and with the real-time indicators. So this is a nice piece of work that sort of combines monthly GDP and real-time indicators for me. And we very much welcome this research. I've worked with Anna a few times on various ESCO work streams, and this one is particularly close to my heart because I've long wanted to be able to use the information that we get in our various real-time indicators to try and get an earlier view of what's happening in the latest month than we can even get from monthly GDP. And I think that this research can help us tap into the wide range of real-time indicators that we've got at our disposal to try and improve the quality of our mainstream economic outputs. So I'm not going to run through Anna's equations at all, you'll be pleased to hear, but I'll start with a bit of a background to make sure everyone's on the same page with where ONS is at, and then a bit of a discussion about how we might use this work and potentially some of the limitations and challenges of it. So for a bit of background, so monthly GDP, I mean, we talk about it a lot, but it's only been in existence for just under 8 years now. So relatively recent. We publish with a 40 to 45 day lag after the reference months, which is pretty fast, but there's always an appetite for an even earlier view of how the economy performed in the latest month. And this is part of my current thinking about how we can use the narrative of what real-time indicators give us to try and evolve the monthly GDP publication to not just report on what happened in November, but to try and give us an early view on that most recent month as well. But I think it's important to realize we have to try and avoid meaningless noise within this, and obviously more frequent data can just mean more noise. So it's important we avoid those pitfalls of using unreliable data. And when I say unreliable, that's both in terms of not being produced for the purpose in which we're trying to use it, but also that it's actually produced regularly and we don't just get gaps in the series. So increased data options are good news for me, but misleading signals in that data could actually be bad news. And even in monthly GDP, there is a natural volatility due to the timing of invoicing or one-off events and so on. So you'll have seen recently that we've switched back to leading on the 3-month on 3-month movement. Okay, it's monthly GDP and that's still in there, but we want to lead on the 3-month on 3-month movement to try and avoid the pitfalls of a single month and trying to give that longer term trend through the data set. And I think it's just getting this balance right between this need for instant data versus reliable data. And that's really where we get to with real-time indicators. So again, real-time indicators, fairly recent. We introduced them actually in April 2019. That was the first release. So within a year of monthly GDP, these followed behind. But it was 3 indicators to start with. It was the monthly VAT reporters, some information on shipping movements and road traffic volumes. And it was a monthly release. So it didn't really have time to settle in, and then COVID came along in March 2020 and completely changed what we did. As Anna said, there was a massive ask on ONS to try and help to understand the economy better, how interventions during COVID were being monitored in as close to real time as possible. So we introduced new indicators, and we published a whole suite of these indicators now on a weekly basis, including surveys that ONS started to run for themselves, like the Business Insights Conditions Survey. And they chose the RTI vehicle, the real-time indicators publication was the vehicle to bring it all together. And as we emerged from COVID, so the publication evolved. Data sets, indicators, they've come and they've gone. So sometimes it's the long-term sustainability of data sources, which is difficult. I mean, during the pandemic, we had information on shelf availability. How easy was it to get toilet rolls in a supermarket? We were monitoring that. There's no need for that now. So some of these things naturally had to drop. Other data sets were externally produced, and the provider stopped producing them. They weren't needed. So that again was stopped. I think Anna mentioned OpenTable. That was one that was stopped by the provider. We had no control over that. Others, okay, we're outside the immediate national emergency, so they started to want to charge ONS to have access to the data. So again, we had to sort of prioritize what was important post-pandemic and going forward longer term. But we've ended up now with around 20 indicators that give us a range of views across various sectors of the economy. And we publish those as weekly data sets, and we provide a commentary around those. So looking a bit around some of the limitations of the real-time data. Firstly, anything that we do that aligns itself too closely with these external real-time indicators can be a bit risky. And I think Anna's seen some of that firsthand in the work that's been done. For example, initially, we were using the Adzuna job advert data set for a vacancy indicator because that was a weekly data set. But then partway through this project, the labour market team, who are the primary user of the data set, entered into a new procurement with a different data provider. So it switched to text kernel. Many advantages to text kernel. It's a larger data set. It's got many more observations. It has granular regional and occupational breakdowns. But the disadvantage of that is it's a much larger data set. It takes a lot longer to process. And for labour market purposes, they only did it monthly. And suddenly this project said, hang on, we need weekly data to do this analysis. So we had to actually run the data set as a one-off and get a back series on a weekly basis to continue this. So that's just an example of where, a provider can change over time because we're in contracts with providers that might change, and sometimes the actual content or frequency of the data set will change as well. And again, Anna mentioned the Revolut data. That's the one used to compare with retail sales and GDP. Well, we didn't start with Revolut data. We actually started with the clearinghouse data, the CHAPS data from the Bank of England. But as we were going along, we noticed that data set was showing a gradual drop off over time in terms of the values. Year on year, it was falling 10 to 15%, and that was a time when inflation was running at plus 10%, and we just couldn't trust it as a data source. And when we looked into it, there was a new disruptor firm in the market. Businesses were moving their business to a different provider, and I think that's a key point with this. Just because you have a provider at one point in time, you have to keep on top of things and make sure your data source continues to be well correlated, and you have to keep testing those relationships over time, because a provider might change, there'll be a disruptor to the market, and sometimes your data set isn't reliable as it once was. But I don't want to sound too negative, because I think this is an excellent piece of work which very much aligns with a lot of what we already do in ONS and what we want to do particularly. So looking a bit more towards the way forward and some of the things we're already doing in this space. As Anna said, the data are available weekly through the real-time indicator. We're going to continue that. We're going to try and put it into more of a dashboard format and move the economic narrative, the texture we put around it, to be more on a monthly basis to bring them together. So a lot of our indicators, although we produce them weekly, we're also now producing them monthly. We're seasonally adjusting them where we can and trying to get that story as to what's happening on the monthly data, to try and help us understand more our data sets that we publish, like monthly GDP and retail sales. Secondly, we have what we call curiosity meetings in ONS, which is where we get together with the various data providers and analysts, and we'll look at the monthly GDP data. We'll challenge the emerging picture, how it compares with other data sources. And in that, we heavily rely on real-time indicators, because they're already available when we get to monthly GDP. They're already published. So this work is a great addition to that model, because it gives improved indicators for comparison. We can see what these real-time indicators mean for monthly GDP, and does our story that we're getting from monthly GDP agree with what the alternative indicators are saying when we get to curiosity. And we're trying to also adapt this work for other data sources. So we've now got access to business-to-business payment data, which is both from the BACS payment system and also from the faster payment system data sets, so that we can quantify shocks to the economy. And there's an article coming out tomorrow on this, where we'll show how the business-to-business payment data showed almost real time the motor vehicle production disruption that we saw last September in the West Midlands. And this alternative data source was much more accurate and quicker than the surveys could show. So again, having this information that we could again get on a weekly basis, feeding it through the model and giving us early indications of how the disruption might affect the motor vehicle industry would be very useful for monthly GDP. And just say a final bit on this, we worked closely with the ESCO team, and we actually got hold of the code used to produce this, so that we can now use that code internally to try out other relationships with other indicators and see if we can take this work further. So we want to trial this on a range of real-time indicators to see if there's other correlations. And I think it's going to work best at the sector level. So as Anna said, retail data with retail sales. We can see uses in the construction industry for construction data. Total GDP is a bit more complicated, because it is so many industries coming together and moving so many different ways with so many different external factors involved. So I think we're going to start with using these correlations to form sector level, and use them for quality assurance then before we consider going wider. And just some closing thoughts, because I'm running out of time. This innovative work gives us opportunities and challenges, I think, really. Key ones being, as Anna's graph show you, that the trend looks good between retail sales and Revolut data, but actually we have to care about the individual data points. And sometimes, although the trend looks good, the movements in individual periods can be very different. Sometimes even opposite directions. So it's important to understand why there might be these divergences, and not to rely too much on individual data points, really. Data availability, I think, as we said, you can never have complete control over the data content. The concepts might change, the frequency might change, the availability might change. So again, interested to how we can minimize the impacts of data non-availability or discontinuities in the data set, and indeed, in many cases, the short time series of some of these data sets. That was one of the key benefits of this model, that we could use it with some of the very short time series that we have. And then finally, just the range of indicators. We've got 20 or so indicators in the real time. Not all of them are weekly, some are monthly, but where can we look next for correlations, or should we consider bringing in new indicators with the express intent of being able to feed them into this model and to correlate them with other key monthly statistics? Or have we missed a trick even, is there some other innovative use of this work that we haven't even considered here that other people can think of that might be useful for us going forwards? So I shall close there on time and say a big thank you to Anna and the team for their excellent analysis, and I'll hand back to the chair. Thank you.
Thanks, Andrew. Anna, just before picking up some of the questions in the Q&A, is there anything you want to respond to there from Andrew?
No, thank you, Andrew, for the discussion and explain, there was already a question in the Q&A about the data and so on, and explain, the real-time data availability from the ONS. And of course, I think one of the things that the model does is, even if what happened this week with this high frequency indicator might be a bit weird based on the past, it should be able to filter out that information when that's not the right direction that the official statistic would do. So we hope our model will be able to do that. Another thing about having actually a large number of indicators, but the model potentially could work. Of course, the fact that we add seasonality means we have to be careful about how we actually would model seasonality of a large number of high frequency indicators. But of course, in theory, if we have more of them, you're able to have more information, so you'll be able to get potentially a better tracker. So it should be okay.
Thanks, Anna.
But thank you for that.
I guess in terms of the questions, maybe there's a few in here around the data issue in particular, how you handle things like bank holidays, the collection pattern for monthly retail sales data and so on. Do you want to maybe just say something about how you deal with these issues within the data?
So is the questions about...
Yes. So the first three questions in the Q&A from Duncan Elliott.
Okay. So Andrea, can you talk about the aggregation one?
Yes. So I'm looking at the questions, so I'm gonna go in order from the last to the first one. So the bank holiday effect, that's a fair point. I mean, to simplify a little bit the calendar structure, I mean, we do not consider the bank holiday effect. We did do an experiment with that, like getting data on UK bank holidays and embedding into the calendar. Results were not completely different, but the modeling was substantially more complicated, but it can be done. But that's a fair point. About the weekly aggregation, so there is a little bit of a sort of standardized approach to deal with this, which is what we follow. So basically, what happens is that when data are when months have more than 4 weeks, what we do is that we take all the days past the 28th day, and we basically add it proportionally to the following week, basically in the next month. Okay, and of course, this following week in the next month is not going to just contain more data, but it's because we're going to basically reweight the observation in the month, because basically we're going to allow for the fact that, I don't know, instead of having 7 observation or 5 observation, it's going to have for example 7, because 2 are carried over from the previous month. And this allows us to basically regularize the calendar and have and embed this into the seasonality structure. And then the one about the structural change in seasonality, to be honest, that I don't know. I mean,
I think so. Sometimes is, remember the model has had many components, right? Has irregular seasonality. Sometimes there's a bit of tweak between them, but we really haven't thought about it, whether there is any major structural change in seasonality in it. Stuart, should I go to the to the
Yeah,
question by
yeah,
Pierre?
do you want me just to summarize that for those that maybe aren't looking at the Q&A? And I guess it's two key questions here. In the post-95 sample, how important is stochastic volatility and fat tails in the model? Because you're wondering, aren't fat tails enough? And the second question is, the real-time improvements brought by new data sources are mainly post-COVID. Is that because the model only started to really learn how to deal with the new data during COVID?
Yes, no, that's true. Of course, we did a real-time exercise over 5 years, and of course, in the beginning, you can imagine you have not enough information, but it comes also from the data availability of the real-time data. The thing about stochastic volatility, remember well, stochastic volatility is very mild. Is there? We think is still important. Doesn't move incredibly a lot over time. Is that right, Andrea? That's what I remember about it.
Yes, exactly. So the point is fair in a sense that it's not strictly necessary as much as the distribution, but it helps in few cases in which like the data becomes a little bit faster moving, and in general it's pretty small. So
yeah, it's pretty small, but it's there.
Yeah.
And I think then there is a question about the ONS data availability that I don't know if Andrew wants to.
Yeah, I think there's a question for ONS colleagues about the availability of the and perhaps Andrew wants to pick this up, but it says the last time the Revolut data were published was the 27th of November. Obviously, have retail sales for December now. The text kernel numbers on the 18th of December contain monthly but not weekly data in November. Will publication of these high frequency data sets be resumed? I don't know, Andrew, if there's anything you want to say on that.
Yes, I can come in on those. So yeah, I think as I alluded to, really, the Revolut data, we are beholden to an external supplier and providing their data, and particularly towards the end of the calendar year, Revolut do turn their attentions to some of their internal auditing, etc. So we do seem to, at the end of the year, have a gap in data sets. We're working on that. Hopefully in the next week or two, we can fill in that gap and bring Revolut data up to date again and back onto a weekly basis. But we noticed we do tend to have this issue towards the end of the calendar year on that. Text kernel, again, because it's such a large data set, I say the intention going forward is that for the detail we have both regionally and for the occupational groupings, that it will be a monthly data set. We did the weekly analysis as an exception to help with this project, just to prove a proof of concept. We'd have to assess the user need of doing it regularly on a weekly basis. We're just trying to catch up still sort of post Christmas break with the monthly processing. So yes, hopefully the monthly will get on track in the next week or two as well. But there is no intention at this stage of regularly producing text kernel on a weekly basis. We can perhaps run some exercises occasionally to give the back series of weekly data for people who use it, but I don't think it will be a weekly indicator just for the sheer intensity of what's needed to process it, really.
Thanks, Andrew. And I guess one final question that's in the Q&A, Anna, for you is, again, from Duncan Elliott on, for retail sales, are you able to introduce sampling error into the model for retail sales?
Sampling error. So the way one can think about it, our regular batch, is a type of measurement error, right? But it's not sampling error. Yes. Let's say the model accommodates all sorts of measurement errors, and that's basically something that's behind it, this idea. But at the same time, not necessarily sampling error, which is something I guess people from NS could compute, right? If they know the sampling error of retail sales. I think it's an interesting question, and it could be an interesting type of model, the one that handled the sampling error as well as this more traditional statistical way of dealing with the time series. So I think it's some kind of research to look at it. But in this kind of approach we have, we thought that the official statistic would be like the golden standard. So in that sense, we're not worried about the measurement error in the official statistic in that sense. But of course, you could have a nice approach in which you have official statistics, you'll be worried about measurement. So you have different ways of measuring that same data set, and you try to do a more measurement error approach. Here we're more like I wanted to increase the frequency of this official statistic from monthly to weekly, and that's why we did the structure in the way we did.
Perfect. Thanks, Anna. And I think that brings us to a close. I think all that's left to say is thank you to everyone who attended. Thank you to Anna for a really interesting presentation. Thank you to Andrew for his discussion. And thanks to everyone who asked a question and contributed to our discussion just now. So thanks again, everyone, for joining. There will, of course, be further ESCO webinars, so have a look on the website for details of those. The video from this webinar will be put online in due course as well. So thanks, everyone, for joining, and we look forward to the next webinar.
Thank you.
Thank you all.
Thank you. Bye.